and the team can.
Okay. Thank you, everyone. And let's start today's season. And today, our Geowebinar number 4. It's about introduction of SuperMap's digital twin 3D GIS technology. And thank you very much for accept our invitation from SuperMap participants. And I will the moderator of today's season, and I introduce today's agenda. And the first is two opening speeches from Mongolian Geospatial Association, our chairwoman, Dr. Bayır Tongtak, and from SuperMap for International Business General Manager, Evelyn Sam. And then our two main presentations about the digital twin and 3D catasters. And I want to invite our chairman, Barton, to make a speech for today's season.
I will start, right?
Yes, please share your screen.
Okay. Can you see my full screen?
Yes.
Okay. So I remember that long time we didn't do anything like this. And last year, I remember we organizing together with our colleague who is working in SuperMap company LLC, and so I remember that last year we already have lots of webinar online version. So this time we again starting one interesting and very important webinar for our Mongolian colleague, and especially for our members in the Geospatial Association. So my name, first of all, maybe someone already know me. So my name is Bayır Tongtak. I am the chairwoman of this organization, and today I'm going to introduce our activity. So, you know, space technology is very, we have lots of, lots of comparing to the China and Japan and other countries, but we are a developing country, and we have some experience, history in the last years, and we started our space technology and application start from 1965, and it was some intercosmos program with Russian and other countries, especially for you know, the some association countries together in this program. And second, we did some data receiver station, especially for telecommunication in space, using the space technology in 1970. And also that year, we also received it, and we also organizing and established meteorological station, receiving some satellite data for weather condition in Mongolia. And also in 1981, we have the one we have the already one astronomer who is from Mongolia and went to this space station in space, and it was one of the good experience in our science technology in Mongolia. And last time in 2017, we already have one small experience for a small CubeSat to the space. It was the satellite small satellite, and this cooperation it's our extra, and my supervisor was joining that, and our supervisor was organizing this project, and she was very successful to send her with her team that small satellite to the space. It was one of the good experience in the last time. And also, yeah, it was in the science space technology in Mongolia. And also we already have global navigation satellite system receiver and application in Mongolia for land management and geodesics in Mongolia. So it was also another kind of space application. And also you can see here, and we have some organization related to the space technology. And there is one National Space Council, and our organization is the one of the member in there. And we are cooperating together and we are still managing some together with the other members in this National Space Council. We are organizing and we are handling some activity for space technology. And there is one new ministry established in this year. It is the Ministry of Digital Development and Construction. And this organization is also now handling and organizing some kind of activity related to the space technology. And there is another Ministry of Nature and Environment, and also Ministry of Construction and Urban Development. There is, Agency for Land Management and Land Management, Geodesics and Cartography. They are using the science and education, and there is lots of universities and private and state universities and institutes under that is Ministry of Science and Education. And also, in the academic part, and Mongolian Academy of Science, including Institute of Geography and Geoecology, Institute of Astronomy and Geophysics. And this year, there is one small part, a small organization established in this year. It was Space Center, and they will also organizing some work starting related to remote sensing and space technology, and some development for a small satellite, and they are focusing on this kind of activity. And there is also business and private organization in this technology, and they are using, and they are one of the good application, and they are handling the application part in Mongolia. And the non-government organization, and there is some part of organizations are using some space technology related programs. And one of our organizations is one of the handling and organizing some activity related to the space technology in Mongolia. So we have some structure in our organization. You can see there is a board member, including nine members in here, and there is CEO, CIO, and they are handling about, they are organizing some activity related to, we are organizing it related to the photogrammeter, remote sensing, and geographic information system, and global navigation satellite system, and some expert groups together. We are organizing related to the space technology activities in Mongolia. And also, you know, we have some technical community and members and stakeholders in our path. And we are organizing every month, every year, we have many activity. This time, we are also cooperating together with SuperMap, LLC, and last time, I remember that we have long time, 5 or 3 or 5 years activity together, and we also there is a lots of company and institute, research institute, and universities and non-government organizations are cooperating with us, and we are organizing some activity related to the remote sensing and the geographic information system, also global navigation satellite system. So you can see in this slide, every month we have the one activity we call a Geo meeting, and we started it 2014, and still today we have organizing this activity every month with 2 presentation and lots of networking community, and discussing some new challenges, new activity together in this meeting. And also every session we have a Geo workshop and or Geo training, and we already have lots of training with our cooperating with our partner organization, and it was very successful during the last 3 years. And also you remember that we are celebrating GIS Day every year in the November, and lots of people are waiting this activity because we organizing it every year. It, you know, more widely, and we inviting private companies and also the non-government organization and government organization and institutes and academic experts. We are together in one day, and we present and our problems, our success, and also we sharing our networking and knowledge, and during this GIS Stage conference, and it is very successful. I remember that it's from the 2014, and since that we started the GIS Day also, and it was very successful every year. And you remember that every year we have Geo Forum, and it is one of the good workshop for us. And last time we organizing one big Geo conference, Geo workshop, cooperating with United Nations, especially for global navigation satellite system. It was very successful for last year. And this year, we are also planning to organizing Asian Remote Sensing Conference in Mongolia. So every year we are trying to organizing one international conference or workshop in Mongolia related to the remote sensing and geographic information system and global navigation satellite system. We have some international activity, including this webinar, and we cooperating some organization in other country. Also, we are sending our members to the other country for our master and PhD course, and sometimes we also joining the international conference and short course. And you can see here we make some mark on the map, and we cooperated, and every year, every month, and every session we try to cooperate in some international organization with our members. And we also have some research project, and one guideline book to Mongolian language. It was also a good project with our members and experts and working groups in our organization. And also we are cooperating with SPRS education and capacity building activity. And it was also another kind of good project for us. And last one is that international global navigation satellite system monitoring and assessment project. It's started from 2018, and I actually we didn't add the two more project in here. I remember that last time this year, we already have one big project related to some remote sensing activity with NASA. So we already have some projects in here. And if you have any questions, and if you have any more activity, if you wanna handle, and if you wanna organizing or cooperating with us, please contact by this social media and also website and email, and we can reply and we can contact you if you have any interest. Please join us. And this year we are organizing Asian Conference on the Remote Sensing in 2022 in Mongolia, and it will be held in October and 2022. So please visit to this website, and you can find lots of information. There is also, I remember that there is they are receiving their abstract and full papers for this conference. So if you're interested, please send us your project, your abstract, and your full paper, and also please share your knowledge during the oral presentation and poster presentation, and it will be also organizing in hybrid version in Mongolia and in online. Also we organizing in online together. ID and any research area, please contact us. And thank you for your attention. If you have any question, I can answer you.
Okay, thank you very much. And I will, again, if you have questions in Mongolian language, and please put in Mongolian language in chat box, and I will try to translate in English if you don't want to English. And yeah, I will share my screen and introduce to again today agenda. And now I want to invite General Manager of SuperMap International Business, Ms. Evelyn Sang, to make an opening speech. And the floor is yours. Evelyn? We cannot hear you, Evelyn. Sorry, still no sound. Yes, now coming. Oh, sorry. No sound again. Sorry, I cannot hear you. Sorry, still no sound. Hello? Really? Sorry, Tunga, did you hear?
I cannot hear.
Yeah, we not hear us.
Cheap hair sound. Unmute. Yeah, it's already unmoved. So I don't know. I can hear you, actually, but I cannot hear Evelyn sound.
Yeah, I saw how we could. Yes, now coming.
Oh, yeah, we can hear you.
Actually, I can hear all of you. I don't know what's going on with my internet here. Sorry for your for this inconvenience. Let me restart. So good afternoon, everyone. I'm Evelyn from SuperMap. We would like to thank the Mongolia Geospatial Association for this great opportunity to present SuperMap GIS technologies. Our team today will share knowledge and experiences on the latest 3D GIS technology and also digital twin applications. So in this virtual conference room, we would like to welcome all the participants from different industries to join us today. We believe that with your interest and enthusiasm in GIS technology and innovation, we will definitely create a sustainable society to benefit the people in Mongolia. So you know that the world we are living today is changing so rapidly, and we have entered into a very new era, an era where digital technologies have dramatically transformed people's lives and work. We hope after all the presentations today, everyone will be interested in SuperMap GIS technologies and be inspired to use it for your specific area of work and research and get the best outcome you expect. So during your journey with the SuperMap GIS technology, you are always welcome to contact us for any questions or for any support. So again, thank the organizer for the event and thank all the guests for joining us. Let us all enjoy the webinar. Thank you. Thank you very much.
Okay, thank you. And also, Mongolian participants, if you have question in Mongolian language, please put in chat box and we will try translate in English. And okay, let's I again share my screen and introduce to our first presentation, exploring digital twins with the SuperMap JS technology, and Mr. Jason Yuan, technical manager of SuperMap software company. And floor is yours, and please.
All right, hello. This is Jason speaking. Can you hear me?
Yeah. How are you, Jason?
Yeah, I'm good.
Yeah, good. Please.
So let me start. All right. So good afternoon, everyone. I'm glad to be here to share the new modes of smart city development, which is digital twin city with all of you. First of all, please allow me to introduce myself. My name is Jason, and I am the technical manager of SuperMap International Asia and Oceania Center. So before our presentation today, I want to clarify one concept, which is about what digital twin can be used in different industries, such as in the health industry, or of course, in the GIS industry. It is a very important scenario for using digital twin concept. So in the urban planning and the construction industry, the digital twin, the geographic digital twins have been popularized in urban planning practice, given the increasing appetite for digital technology in the smart cities movement. These digital twins are often proposed in the form of interactive platform to capture and display real-time 3D and 4D spatial data in order to model urban environments, and the data fits within them. So based on our experience and my understanding, I put the content of digital twin city into these three parts. The first step of digital twin city is modeling. We need to use some method to generate the model for the whole city. And later I will show you about two new methods to do modeling, which are oblique photography or beam and beam. Maybe they are not new, but they are pretty popular and common used these years in GIS industry. And the second step of digital twin is visualization. We need to based on some GIS technology or visualization technology to show all of our city models, including the building and underground, maybe pipeline or geobody, and underground, the building, the road, the terrain, all of them in different terminal, such as based on 3D GIS platform or VR or AR. And the last one is the management application. It is including the planning, design, construction, and O&M. O&M is operation and maintenance. So in different stage of city or for building, we can use different function to show the feature of digital twin. Okay, so our outline today will be these four parts. The first one is oblique photography, and the second one is beam. For these two parts, I will show you this the format of the methods of getting data of a city and what kind of features they have, what kind of advantage and disadvantage of these two types of data. And the third one will be management application. I will show you in different stages to help us to improve systems. One, there will be some cases. Okay, so the first part is oblique photography, developed in industry. Oblique photography captures images from orthogonal and will be control the UAV to fly around the city, and it will take pictures for one object from different angle, such as for the building in the center. We can see it takes pictures from different direction, and based on them, we can use some software to generate the point cloud, and then convert point cloud to tin, the TIN, and based on tin to generate the DSM, and finally we paste the texture, paste the texture or image to the DSM. We can get the 3D modeling for a big area. This is one of the example we did in a city of China, and we can see for this area, the model is very detailed and it looks very real. And there are some advantages of oblique photography modeling. We can call them as efficiency and low production cost. So the advantage of oblique photography is very obvious. And based on the oblique photography module, we can do some further function or some further operation based on the modeling we get, such as we can overlay the oblique photography with vector polygon to extract the building or the object from the continuous oblique photography model. And based on this, we can achieve a lot of functions, such as for this one, we just such as on the website, we can draw a polygon and give it some attributes, then submit it. After that, every time when we click at this building, we can get the attributes. But actually, the attributes was stored inside of the vector data. And so based on this, we can create the thematic map to render the building in different color for the whole city. And we can achieve more functions, such as management of 3D real estate for urban complex building. For example, the realize sophisticated management of complex building complexes, and realize comprehensive expression of multi-property rights buildings in the same space, or applying the 3D results to the work of confirming the rights of registration in the registration and acceptance stage. And the last one is, for example, the integrated 2D and 3D data will be shared by departments to further explore value. So the oblique photography. And the second topic of my presentation is about BIM. So what is BIM? Modeling. And it is a definition by American National BIM Standards Association, like a digital expression of a construction project. And it is a shared resource to provide a reliable basis for all decisions during the entire life cycle of the facility, from construction to removal. And at different stage of project, different roles insert, extract, update, and modify information in BIM to support and reflect their respective responsibility in the collaborative work. So the BIM will be very helpful and very necessary in digital twin. And this is showing the global development of BIM. The first is in US. The US GSA department is an advocate of BIM technology, and until now, there are more and more countries' governments rise the standard of BIM in their country in different times. So the BIM plus GIS is very necessary in the next stage of using BIM. Like the BIM software or BIM model itself can be used in the design, plan, and construction stage of a building or of a construction. But in the operation and maintenance and maybe the management stage, GIS can help a lot for it. And so BIM plus GIS can bring the building from macro to macro and from outside to inside. Okay, so that's about BIM. And based on these two types of data, the oblique photography and BIM, what kind of function or what kind of application we can achieve in the digital twin. So here I divide them into 4 stages for building. The first one is input and visualization. The second one is in the planning, the urban planning stage of urban planning stage. And then the analysis and simulation. The last one is maintenance and sustainability is input and visualization. And in the oblique photography, SuperMap cannot generate the oblique photography oblique photography module, but there are a lot of common used software we can use, and we can get the data from them, such as the Stretch Factory, the Contest to Capture, or like Pix4D or PhotoScan. All of them are the popular software in generation, in the oblique photography generation. And in SuperMap, what we can do is we can put the oblique photography module into a GIS environment, and they can be shown together with other types of GIS data, including the terrain data, the satellite image data, and the underground to body and other types of module. And from the video I'm showing now, this is per Terra, which is a UAV to the SuperMap. And it shows a very detailed module on the mountain. And we can see all of the details from this module. And there is another example. Another example is for whole city, which is 3.2 terabyte oblique photography module for the whole city. And we can see it shows the factory in a very detailed way. And for the whole data, it doesn't need to take a long time to capture all of them. Only a short time, maybe within 1 month, we can get all of the information like this very easily. Just need to get the permission to fly UAV around this city. So in the industrial chain of oblique photography, the SuperMap, which represents GIS platform, is in the middle. And in the earlier, we need to use UAV or use the oblique camera to fly and to automated modeling. Then we can import all of them to the GIS platform. And after that, we can construct or establish different industry applications. And talking about BIM, actually it is similar with oblique photography. SuperMap cannot generate the BIM model, but we can use it. But we can use them, such as for different BIM software like Revit, Bentley, CATIA, and for different formats like CityGML or IFC or FLT or GLTF, this kind of format, we all can support them. So we can see from Revit, from Bentley, from CATIA, on the left side, they are in this kind of model are in the beam software in different beam software. And on the right side, it shows totally the same in the GIS software, which is SuperMap iDesktop. Okay, so talking about input and visualization, then next I want to talk about the planning and design. So there are some problems in the planning and design, such as collaborative design, ground and underground planning, multiple planning, conflicts, and scientific planning. So in this stage, there are some applications like online design, parametric design, 3D design, model browse, internal room, and scheme comparison. So this is what we can do in a digital twin platform. So first, we can say this is a real case we did in Hong Kong, and the whole city is generated, the model is generated by oblique photography, but some of the important building or the key building, we use beam model to render it. And it can help us to do the urban planning function, such as the scheme compare. We can put different model to the same building in the same view to compare the scheme. And also we can compare it with the street view, with the current street view, and we can set it with the photo to show the differences. Like after, if we build a new building here, what will be the differences? And next function is about planning approval, such as the designer, they can submit their plan to the system, to the website, and then we can see, and then the user can see detailed information, the detailed parameters of this building. Then we can choose to pass it or not. And the next one is parametric design. So that is, if I just want to say, like I just roughly to build to add a building here, like with different floor, with static static shape, then how will it look like? So we can use the parametric design to easily add some new building and to change the height, the position of them. Okay. And in the urban planning, there are some rules, such as the setback. Setback means the building line refers to the boundary line that controls the buildings along the street, sent to the street. In the digital twin, we can easily to get all of the model of building and based on the analysis to see which building is illegal. And in the 3D design function, there are a lot of 3D analysis, such as the openings analysis it shows just now, and that is the sky view will be affected by the new building or not, and also the shadow analysis. We can based on it to simulate the shadow in the city, and the float analysis or the floating simulation. We can know like which part will be float, and based on the terrain, we can do the slope and aspect analysis. So there are a lot of 3D design function can be achieved in the digital twin application. Like this one is to analyze the skyline analysis. Okay, and there are some more cases such as the planning modeling, the decision support, the decision monitoring, and others. So now we go to the next stage of application management application, which is analysis and simulation. So there are some 3D analysis functions based on the model, such as cross clipping. We can draw a box to clip the building to see the inside of it. And it also supports the beam spatial query and attribute query. Also, also there is a function of 3D spatial relationship judgment. We can achieve to query objects based on query conditions. It can be contain, separate, concede, intersect, be included or related. And for other spatial analysis like view sheet analysis, shadow analysis, extract skyline, section map, terrain contour map, terrain slope aspect map, they are allowed. And all of them of the results of analysis can be exported as 3D solid model. And in the last one, the maintenance and operation and maintenance can solve some problems like incomplete supervision or weak early warning and emergency scheme or poor management and facilities. So we can achieve the functions like video supervision, emergency management, asset management, equipment management, safety management, and indoor navigation, such as for a skyscraper maintenance management. This is the Shanghai maintenance platform. The Shanghai Tower is the second highest building over the world, highest one in Asia. For this, establish all of the detailed objects inside of it, and for all the detailed information, the parameters, we can easily to check from this system. And we can achieve to the parse query and positioning to get the location of every object. And also the viewpoint management, such as if there is, we can add some new viewpoints, and in the future, if we move around, and we can easily to go to this viewpoint we stored earlier. And some video supervision, like it can connect with IoT, which is a CCTV camera. Hello? Yeah, sorry, it seems my network has some problem. And yeah, let's continue about the functions. Yeah, about the features here. So next is about the emergency management. Simulate the emergency situation and to have some emergency plan to to management of emergency. And the aspect asset management, such as we can see all the detailed information of each, and some problems report, like we can connect with the mobile, and we can based on the mobile to achieve to report the problems when we do the operation and maintenance function. Okay, so the last part of this presentation, there are some cases. First of all, this is a career of all. First of all, this is a smart city management function, and it provides us the functions like video surveillance, the labor supervision, the environment and monitoring, the progress supervision, and video conference equipment monitoring, and others. The data size is 252 gigabytes, and the number of 3D models is reached to 3 million. And there are some other functions or other cases we did before, like equipment check, facility maintenance, park emergency, consumption analysis, and optimization. And the last one is security facility integration. So all of them can be easily used in the digital twin technology. Like in the BIM operation platform, we can achieve the like daily operation, the sciences, command, equipment operation, scheduling policy, and we can show the whole city view in a digital way in a big screen, and other applications like building overview, key area display, building management, weak power management, fire warning, or video management. Okay, thank you all. This is my presentation.
Thank you, Jason. It's very interesting presentations. If you have a question, please ask to Jason. And let's wait to questions. Or if you have question, and please put in chat box in English, in Mongolian language, and then we try to translate to English and answer your questions. Okay, question, and we will continue after second presentation, some question and answer section to continue. And let's move to second presentations about SuperMap practice on the 3D cadastre application. Mr. Qin Zhang, technical support engineer, SuperMap software, and please present your case study.
All right. Good afternoon, everyone. This is Qin speaking. So can you hear me? Okay.
Yes. Please put in full screen.
Yeah, can you see my screen? Hello?
Yes.
Yeah, okay. Good afternoon, everyone. This is Qin speaking. I'm a technical support engineer in SuperMap Asia and Oceania Center. Today, I'm going to have a presentation about SuperMap solution for mobile surveying and 3D cadastre. For cadastre management, we know that the most important thing is to get cadastre data. The data can be from images, city data, as well as surveying. So对，因为刚刚我的内网也问。 Okay. Sorry. Our internet is not good. I think may I from the beginning. Let me from the beginning. So good afternoon, everyone. This is Chin speaking. So I'm a technical又连回公司了，现在连上你了，现在。Oh, sorry again. Let's go on. So I'm a technical support engineer in SuperMap Asia and Oceania Center. So today I'm going to have a presentation about SuperMap solution for mobile surveying and 3D cadastre. For cadastre management, we know that the most important thing is to get cadastre data, and the data can be from the images, CAD data, as well as surveying. So at the beginning, I'd like to talk about how to get data through SuperMap iTemplate, which is a mobile app developed by SuperMap iMobile. So now let's take a look at the first section of mobile surveying. Firstly, let's have a look why it is necessary to do surveying. Even we have images or CAD data, but we always need to verify the data whether there is any change or not. So we need to assess and update the data. Then we should think about how to connect the data, how to manage the collected data, as well as how to finish the collection work. So firstly, we may want a device for data collection. We may consider that how to synchronize the data, maybe connect the data offline or online, as well as how to connect data efficiently. So here needs some points we should consider, like how to capture the asset and in inventories and perform inspections and the editing and analysis capabilities. And if you want to import store the spatial measurement and computational and so on. So then with the device, you may want an easy way to use it. It should be easy to connect data. It can support take photos or edit data conveniently. In addition, it is also a key point about how to synchronize the data from surveying workers or synchronize surveying results to the office so that we can modify or update the data in time. So here, as you say that sometimes we need to synchronize the connected data through the surveying workers or synchronize the surveying results to the office. So here we can update or modify the data in time, and then so here we have some content or point or content need to be considered to synchronize, such like send the works data to others, get updates made by others, or configure the update directly while having connections, or copy data directly to the device. So this is about the surveying work we need to consider. So now we have SuperMap iTemplate that can meet the above requirements. And the SuperMap iTemplate is a universal mobile app you don't need to worry about the development work since it is no development required, and it can be used directly after you download it to your mobile. So with the SuperMap template, we have several functions can be achieved, such as the mapping and view the 3D scenes, the AR functions, and the navigation, and also create the thematic map. Of course, the surveying is one of the important function of it. And also we can do the plotting and the data analysis with this mobile app. And with this template, SuperMap template, we can easily share the data through different workers, or you can easily share your data from the mobile terminal to the desktop terminal. So here, let's take a look at the data collection. The app template have many ways to collect the data. You can collect the data by point, or collect the data by drawing polygons, or collect the data by line, and also you can collect the data by GPS. And also we have the easy way to collect the data by tracking, as well as, or it can take pictures and also upload it to your mobile terminal. And also it has the edit the result to contain to project requirements. Firstly, we need to create a connection tablet. So if just like the buildings, the road, and other objects you want to connect. So here's the first thing is to create a template, and then connect the data in mobile. After that, we can also process the data in the mobile. Of course, you can also edit the data after share the data to the PC terminal, and also we can easily analyze and apply the result. Also impaired some advantages of field serving. With this app, it can save your memory and save your power, and also I save the mobile data, and also it is high efficiency, and it can be searchable and dynamic interaction. So the next function is mapping. It is easy for you to do a mapping in the mobile terminal. You just need to import the data or connect the data first, and then do the thematic map, so that you can either need to get a thematic map, just like the range style map or unified label map. Here lists some styles of the thematic map, which can achieved by the mobile terminal. And also the data analysis. The spatial analysis is the most important feature in GIS field. So in the mobile terminal, it is also the spatial analysis can also be achieved. So you can easily and convenient to do the spatial analysis after you connecting the data, such as you can do the buffer analysis and also set selection analysis with the mobile. And also the navigation of the SuperMap template has the capabilities of indoor and outdoor integrated navigation. As you see here in this video shows, firstly, you can navigate in the 2D map and then switch to the 3D models indoors. So, and also the video map is supported. So what is about the video map? It is integrated with AR technology, and with this capability, you can view the 3D models with AR effect, just like to walk in the AR buildings, and also the AR technology makes us to check the make us to check the to get the so we can get a high precision precision based on the location indoors. So here are all features of the template, just like the mapping and data collection and 2D and 3D integrated viewing or navigation or indoor and outdoor integrated navigation, such like this, you can achieve with SuperMap template. And also it has high performance map operations. And the tablet can be used in many fields. To some cases that uses the template, just like the National Census Project, POS survey project, and land survey project. With SuperMap template, you can get high efficient to in this field management. And I mentioned that with SuperMap template, you can either need to share your data with your colleagues, or you can share the data from your mobile terminal to the desktop terminal, and the data can be displayed in multiple terminals. Let's take a look at the advantages of SuperMap template efficiency tools, and plan effectively for set location and observation. And it is it can achieve the automate task and also save the historic data, so you don't worry to lose the data you collect, you connect, and also it has the asset maintenance, which is redundant data. And the second step of the disaster. So here I want to talk about this. We will summarize this content. Firstly, let's take a look at the background of 3D cadastre, where we need to build the cadastre platform. Here we list some factors, just like the because of the population growth and existing land supply imbalance. And the second one is about the intensive use of space above and below land parcels, which mean us to manage the space on the ground or underground. And also, we also need to know the legal status on utilization of space. And this fourth one, we often in the traditional way, it is also difficult. It has difficulties to reflect the spatial aspect of rights into the cadastre registration systems. So why we need to build this 3D cadastre, and also higher and higher, and then with this 3D technology development, it is possible to achieve this 3D cadastre management. So as you see here, we the intensive use of space just like the underground pipeline, the tunnel, the shopping center, and others. We need to manage all this space in one platform. So what technologies we need to consider to achieve this 3D cadastre platform? Firstly, we need to update the 2D and 3D models for buildings. The traditional way we always only have the 2D data, but so the first thing is to convert the or update this 2D data to the 3D models, and then we also need to connect the attributes with 2D and 3D data. So no matter in the 2D query or 3D query, we can achieve the information query of each resident or each building. And also we need to build a unified standard for the cadastral data. And also the legality checking is also one of the point we need to consider, whether the buildings or the design meets the requirement. And also we also the platform can publish the public information. So here it is the workflow of the 3D cadastre platform building. Firstly, which also it is the most important is the data management. Data such as the building's information or the household information or the owner's information, such like this. And the business data is non-spatial data, and the second one is the spatial data, just like the vector data, image data, or the model data related with the cadastre. And the second one is digitization. Here, actually, the second one is about how to get the 3D cadastre, how to get the basic data of the cadastre. We can get the data through the surveying, and also we can digitize the digitize the images, or to get the data, or we can convert the CAD data to get the vector data. Besides, we can also besides, we can also get the get all this data integrated. Also, yeah, as I mentioned that there are a third way to get the digitalization data. The first is by surveying, and the second way is to digitalize digitize the images, and the third way is to convert the CAD data to the vector data. And then with the 2D vector data, we can do the 3D modeling to get the 3D cadastral data. Besides, we can also get the 3D data from the object photography data, and also we can integrate the building modeling data and object photography data to display the cadastral results. And the last one is the visualization. After we get this 3D modeling data, we can display it on multiple terminals, just like on the desktop, or on the website, or on the mobile terminal. And then we can also do some management of the data, or we can manage the information of the cadastral data, or we can do some analysis to better design just like the community or the city, so we can get an integrated platform. And then let's take a look at this 4 aspects separately. The first one is the data management, how to manage the different types of data. Firstly, as I mentioned, it the business data. SuperMap has strong capabilities of managing the data. No matter the file data, or the data in the database, or the web or the web engine data, we can all manage it with SuperMap SDX, so we can integrate the business data together. Just as here shows, with the SuperMap at desktop SDX, we can integrate the history data or the daily updated data together to construct a unified cadastral database. And for the spatial data, there are vector data, image data, and the models. The different data all can be managed by SuperMap SDX. So the data can also be managed in the files, or it can also be managed in the databases. So you don't worry about the different kinds of data, how to manage them. And the second one is about the digitization. So here, as I mentioned, that for the first way is to connect the data on site, and the second way is to is to digitize the image data, and also we can get the vector data by convert the CAD data. You see here we have the cadastral vectorization plugin in SuperMap at desktop. This plugin can make the digitalization easier, and you can get the result much more easier and convenient. So firstly, you can link here and take a look at the video. So you can import the image data to the desktop, and then draw the rooms. After drawing all the rooms, then we can draw the outer contour. So this way to get the wall of the building. So we have many tools to help you to do this operation. So after the we can use the wall clip to get the wall of the house. So we can also draw the windows, the doors. And you see here, after the operation, we can get the walls of the building easily. And then we can copy the walls to different floors. Then we can view the results with 2D and 3D integrated display. So here we can see after the operation, we can get the results of the cadastral result, and also we can view it in the 2D map and the 3D scenes. For the CAD data, we can just import the CAD data to SuperMap at desktop, and then convert the CAD data to the vector data. And what next we need to do is to adjust the data to the correct position. So after that, we can get the cadastre result. And here of digitalizing in SuperMap, here we can see that it has strong customized service and quick reaction for special requirements, and it has automatic database management, and it can also integrate integration of 2D and 3D, automatically construct 3D models based on 2D data. And also it can access to many types of database such as SQL Server, Oracle, and others. And we can get the data efficiency. And also we can quickly connect with the database. So and then the next one about the 3D modeling. as the second digitalization talking, we know that we can firstly get the 2D data by digitalization and then build the 3D models and for the oblique photography to get this 3D model. As here there are many advantages of using oblique photography, and we can also have many methods to optimize the performance of the oblique photography, such like the texture compress, data types generation, and also store the oblique photography through MongoDB. All this can make you view these things the SuperMap efficiently. In addition, we have many. We also provide tools to process the oblique photography data, so you can make it much more perfect. And then we can also get the building bottom surface with the deep learning. So after that, we can get the 3D models quickly. And the second way is what I just mentioned. It is about the stretching from the 2D data to the 3D, and then we can get the 3D models quickly. And you see, we can display the cadastral and view them associated. So we can check each floor and also each rooms. Then we can also integrate the models and the oblique photography. So we can check the information on the photography, oblique photography. Well, with this integration, we can do like we can use it for the planning application system. So we can verify if do the above ground space verification or do the recognition range box to check whether it is exceeds the readiness or not. Also, we can do the above underground elevation checking and above underground building range checking. And also these 3D models can also integrated with the team data, and these 3D models can also merge with oblique photography data, and these 3D models can also integrate with the water effects and also the video maps with the oblique photography. All this data can be integrated into one platform. So here we have a question about why we import models into GIS platform. Here give the answers just like because it is lack of geographic information and it cannot integrate it with terrain, and it has no performance with massive data management, and it cannot do the spatial analysis. So after you import the models into a desktop and manage the different models in the SuperMap, you can solve these problems. Besides, in the SuperMap, we can also make yours much more beautiful by adding the 3D symbols. Just like we provide the 3D symbols, just like the trees, fire hydrant, their cars, and others. And also we can you can make a water effect in the 3D, just like here. You can add the street light or the road or the water surface or the trees. All these 3D symbols can be added in the SuperMap at desktop. And the dynamic water surface symbol makes the scene vivid. So how to solve the unified measurement of multiple source data? As we just to know that we can integrate the object photography data and the modeling data or the beam data, and all these different formats of data can be managed in SuperMap with unified formats. It is S3M. With the S3M, all the data can be managed with a unified with a unified format, and it also can make the management easier. And here, the advantages of S3M, just like it supports multiple sources of data. Just like the beam data, the object photography data, the modeling data can also be generated with S3M format, so you can manage them unified. And the S3M can keep the data security, and also it is a small file web transfer to make you manage it easier. And so it can either to render these 3D scenes. And after these scenes, and then we can publish these 3D scenes through SuperMap as server. And after that, we can achieve the multiple terminal display, just like we can display the results on the web terminal with SuperMap with WebGL 3D. The SuperMap Client 3D for WebGL is a full-featured 3D WebGL client, which is based on Caesar and can be supported to many browsers. And it is a lightweight and convenient, no plugins required, and it is based on JavaScript and easy to development, and also easy to expand API. With the 3D WebGL, we can achieve multiple functions, just like you can do the clip on the models, and also do the measurement to measure the distance or the errors of the things, and also do this 3D analysis, just like the availability analysis, view shed analysis, something like this. And also we can design these things on the different terminals, and also we can visualize the 3Ds on different terminals, and also edit the 3D models anyway on the different terminal. So here, just like we can also view these things on the mobile terminal. And also we can build a platform to manage this 3D cadastre, that we can achieve the information query to query the information of each floor, and to check the apartment diagram and the household information. Besides, we can do more for the 3D for the in the design stage, just like we can do the height control analysis. So we can do the legal distance detection. So we can know whether the design the designs meet the planning requirement. And with this really legality rules box, we can easily to know which buildings is meet the requirements, or which building is not. It doesn't meet the requirements. So here, let's take a look at some cases. The first one is this 3D cadastre management in Finland. This system just manages this system use the oblique photography to manage the 3D cadastre in the Finland. We can search the information, the apartment information, and this system manages the household information. And also the 3D cadastre. This platform not only has the oblique photography, but also integrate with the 3D models. And also here you can see the underground pipelines. So it is an overall a management system. And also we can construct a smart community to manage the communities, to manage the buildings in the community. And here that we can check the household information. We can know the owner of the house and the families of the household. And also we can check the address of the buildings, and who is living in this house. And also manage, it can be managed, can manage the apartment diagrams, and also do the statistical information, statistical analysis, such as to do the household statistic and the types of the household. And also it can be checked the associated with the 3D models and the attributes table. So here we can either need to know the information of the household, both on the 3D models and also on the forms. So let me make a summary. So with this 3D cadastre, we firstly need to solve the data management issue, and then we need to digitalize the data. After that, so we need to do the 3D modeling, and after that, so we can then we need to build a system to display the 3D models or 3D things, as well as we can manage the household information, the buildings information, and also and some necessary analysis tools for in the platform. So with SuperMap products, we can integrate different types of data and make the data make the data making or 3D modeling efficient and also effective. And the plan with SuperMap a client for WebGL, which can make the platform flexible, so you can expand your requirements in the platform or expand the functions of the platform. So I think that's all from all my presentation. Thank you for your listening.
Okay, thank you very much, Ms. Chin. And I have one question in chat box. Maybe Mr. Jason or Ms. Chen, can you read that questions and please answer?
Let me answer the first question. Do you share PPT or public? Yeah, I think we can share our PPT for you after the webinar. And the second question is about what kind of equipment do you use to connect data for photogrammetry? Actually, we the oblique photography data. The data need to be get from the third. Yeah, for yeah, the oblique photography can only be get from the professional data collection factories. So our products can access the oblique photography data. So I don't know if you get it. And the third one, do you have own base map? Yeah. I just mentioned that we GIS tools provider. We don't provide any data or base map. So I think for the data part, we can use the open source data or the data collected from others.
Yes, thank you. And any other questions? If you have questions, and please open your microphone and ask, or you put in chat box. Okay. Any more comments on Jason and Evelyn and Baritonga? Okay. If no questions and no comments, and how about close today webinar, and you very much again. Accept our invitation and the wonderful presentations, the application of GIS in 3D map and the digital technology using SuperMap software. And thank you very much all participants, and shall we close today's session? Hello.
No.
Yeah. Okay, thank you. And our next webinar will be held in June 22 about video technology application in China and international level. And thank you very much today activities, and thank you again to accept our invitation to present your wonderful work in geospatial application in SuperMap. And I will close today's session and see you on next time.